Welcome to the Siberian Arena ICS SCADA Demo. We're going to start the scenario by activating it through the UI. The web UI allows you to start any scenario you want. In this demo system, there are only 2 scenarios. When we start the scenario, we can select a unit code and amount of students. Currently, the scenario is loading up the machines relevant. After it's finished loading, we can start the operator, which will show the students and the lecturer what's the situation of every student in the current scenario. We're starting up the operator now. After initializing the operator, it will allow us to start the scenario and later on log in to the system. I've started the scenario now. Now we'll log in into a student account. In order to log in, we use the Siberian student client, which allows us to log in. In this case, we'll log into the S10 system. After logging in order to start, we need to go to Tasks and press on Start. That will display a welcome message that will explain the scenario, and afterwards it will show the first task. This scenario in particular is about attacking a terrorist organization that has been monitored by an intelligence agency. The intelligence agency has recently found out that the terrorist organization has purchased SCADA systems and various chemicals, and is suspecting that the terrorists are trying to manufacture various chemical weapons. The first task is using the backdoor of the agency in order to gain access to the network, finding out which IP address is the IP address related to the PLC of the SCADA system. Three, two, one. Now we'll solve the first task. The first task needs 3, 2, 1, go. Now we'll solve the first task. The first task demands from us to find the right machine or the right device that has an IP address and the port open of a PLC. If we research this version on Google, we'll find out that the standard port for this kind of S7 SCADA device is 102. In the interest of time, we're going to scan the correct IP directly, but in a normal situation, we'd scan the entire network. After finding that this is the correct IP, and including the information that this is the PLC which we're looking for, we can input this IP address into our answer. Then we can start the second task. The second task demands to use the ISF master module that allows us to scan additional information about the SCADA system. In this case, we want to find out the article number, or in our case, the specific SCADA device that they're using, because various SCADA versions have various SCADA devices with different power levels and abilities. So we'll use this module. After activating the module, we need to choose a target and a port. And the target is obviously the device that we found before. By checking the status of the device, we can find out if the terrorists have started working with it, if the CPU is running. That does not yet mean that they've started the systems and started producing the weapons, but it does mean that they're on their way. After running it, we can find out that the specific device is this article number. Now we'd like to check the CPU we've talked about. Like I've said before, there's a set of pre-made scripts on this machine. In a normal scenario situation, the student would have to make his own script. In this case, we'll use a small script that checks the CPU status. The script is only about 10 lines long, and the students will be able to replicate this kind of script pretty quickly. By running the script, we can check the CPU status. The status is that the CPU is running. We'll copy the status and send it to our answer. The next test is the fourth task, and it demands us to get the SCADA output. If we look at the SCADA device, when it's running, it sends information to the various parts. The information affects whether the parts are running, whether the sensors are sending data, and so on and so forth. In this case, it's an 8-bit setup that allows us to see when the engine is running, and the rest is irrelevant in the smaller scope of the demo. In the larger scope, there could be up to 8 or 10 or 20 devices running at the same time. Therefore, there will be needed more research. In this case, we'll just check the output when the device is running. In a normal situation, the device would be running automatically. For the interest of proper volume control in this video, we've left it offline until the moments that we need it. By running a check output script that again the student would make by himself and now is a lot more complicated than the previous one, we were able to find out that the engine was running while this check was performed. In this case, we can use that as an answer to the question whether the PLC is running some sort of device. In the next part, we'll be shutting down the system from afar. Let's enter this answer. Now, the agency basically asks us to stop the device from running, and even more than that, sabotages in a way that it can start running properly again. So what we're going to do is again use a script that the student can make by himself by the end of the course, and attack and flood the system in a way that will force it to stop. The script in this case is flood_stop.py, which we've created for this demonstration, and we'll use it on a live system. Now we'll notice that the system stopped even though I did not touch it. This is a sign that the attack was successful, but for us from afar, we wouldn't be able to tell. So after such an attack, we would like to check the outputs again to see that the device has stopped working. Another thing to note, this flood attack actually managed to prevent this system from working at all. No matter how much it tried to start it, it will not. In this case, let's check the outputs and finally answer the last question. The outputs are now all turned off. In this case, we've succeeded in our assignment. We have now finished the scenario, and if we'll notice here, we have been marked as done. Thank you for watching this video.